All right, here we're going to talk about multiplying fractions. Right, before we get into multiplying fractions, we'll just talk real quick about just multiplying, what that means, like visually speaking. Right, so if I have 2 times 3, well, here I have 2 blocks going across this way or going up and down, and then 3 blocks going across. And if I multiply those, these 2 get multiplied by those 3, and we end up with 6 total blocks. So 2 times 3 equals 6. All right, does that make sense what we did there? We have 2 this way, we have 3 that way. When I multiply them out, it makes it, instead of just like a line with 2 times 3 makes it a 2-dimensional thing where I actually have 6 blocks in there, so I get 2 times 3 is equal to 6. Right? We can use the same principle to try to understand what's going on when we multiply fractions. All right, so if I want to multiply the fraction 1/2 times 3/5. Right, so here, this vertical side represents just 1. Notice I split that into 2 pieces. Right, so if I just do this first one up here, that's 1/2 of that side, right? It's 1 out of those 2 pieces. Right, along the top, right, that whole stretch there represents 1, but I cut that into 5 pieces, right? So each one of those is 1/5, and I have 3/5, right? So I'm going to color in 3 of those pieces up there. That would represent 3/5, right? 3 out of those 5, right? And then just like here where, everything overlapped, this line going across intersects with these 3 up here, and I end up with 3 pieces out of a total of 10. Right, so 1/2 times 3/5 equals 3/10. Right, the 1/2, the 1 out of these 2 goes across and intersects with the 3 out of these 5. Right, so that gives us those 3 there, and the total number of blocks we have in there is 10. Right, so we end up with 3/10. Right, another example of this, 2/3 times 4/5. Right, so here, the vertical side represents 1. It's cut into 3 pieces. I want 2 out of those 3. Right, so I'll take 2 out of those 3. The top part represents 1. That's cut into 5 pieces, right, because this second fraction is in fifths. And I want 4/5. Right, so I'm going to color in 4 of those pieces at the top. Right, so on the side I colored in 2 out of 3. On the top I colored in 4 out of 5. And when I intersect those, right, so everywhere those colored in ones meet up, I color in those squares. And how many does that give me? 1, 2, 3, 4, 5, 6, 7, 8 out of a total of 1, 2, 3, 5, 15. All right, so 2/3 times 4/5 is equal to 8/15. Right, so just to give you a visual image of what's going on when you multiply fractions, this is what's happening. Just when you multiply a 2 times a 3 and it creates that, that grid of 6 squares, you can think of the same thing as when you're multiplying fractions. All right, so 1/2 times 3/5. Again, the 3 end up getting colored in out of a total of 10. I get 3/10. The 2/3 times 4/5. The 8 end up getting colored in out of the total of 15, so I get 8/15. Right, now, how do we figure that out without actually drawing these boxes and squares and stuff and coloring stuff in? Because when we get bigger fractions, that might be a little bit inconvenient for us to have to do. Well, to get your numerator, your top number, right, for both of these here, the numerator came from the total number that we had colored in. Right, which was, for this one, it was 1/2 times 3/5. It was the 1 on this side multiplied by the 3 on this side. Right, so 1 times 3 gave us that 3. Right, for this one, the 2/3 times the 4/5, the 2 on this side times the 4 up here. Right, the 2 times 4 gave us the 8. Right, so to get that number that we colored in, to get that numerator number, I just multiply my numerators together. Right, 1 times 3 gives me the 3. 2 times 4 here gives me the 8. Right, so to get the numerator, I multiply my numerators. To get the denominator, the bottom number, it was the total number of pieces that we had in our final block. Right, this block here had a total of 10 pieces. Well, where did those 10 pieces come from? It came from the 2 pieces on this side times the 5 pieces on this side. Right, 2 times 5 gives us the 10. For this one, we had 15 total pieces. Right, well, that came from the 3 on this side multiplied by the 5 on this side. 3 times 5 gave us the total of 15. Right, so to get our denominator of our answer, we multiplied the denominators from our original fractions. Right, so if I didn't want to draw these pictures and I had to do just 1/2 times 3/5, well, 1/2 times 3/5 is equal to 1 times 3 over 2 times 5, which equals 3 over 10. Right, I just multiply the top numbers together, I multiply the bottom numbers together, I get 3/10. Same for 2/3 times 4/5. Right, 2/3 times 4/5 equals 2 times 4 over 3 times 5, which is 8 over 15. Right, same answer we got from filling in those blocks and coloring in the squares there. Right, so when you're multiplying fractions, to get your answer, you just multiply straight across. Multiply your numerators together and multiply your denominators together. Nothing else to it, nothing fancy going on, just multiplying straight across. That's how you multiply fractions. Drawing these pictures here and showing you how that works, hopefully that gives you a visual image of why we do that, right? To get the total number that we fill in, right? Because we have 2 filled in on this fraction and 4 on this fraction. When I multiply the 2 times 4, that gives me the 8 that I have filled in here. To get the total number of blocks in my denominator, well, it's 3 on this side times 5 on that side. 3 times 5 gives me the 15. Right? That's where those numbers come from. That's why the rule is for multiplying fractions that you multiply straight across. Right? So hopefully that makes sense as far as why we do that. I'm going to pause the video here and erase these pictures and put up some more examples of multiplying fractions. All right, so I put up here a few examples of multiplying fractions without drawing all those pictures, and we'll see why why we want to have those rules and why we don't want to have to draw those pictures every time. Right, so 3/7 times 2/5, again, multiplying two fractions, just multiply straight across. Right, my numerator, 3 times 2 equals 6. My denominator, 7 times 5 equals 35. Can I simplify that fraction at all? I don't think so. Right, 6 is 3 times 2, 35 is 5 times 7. They don't have any factors in common, so my answer is just 6 out of 35. All right, now imagine if you actually try to do this like we did a couple minutes ago with all those pictures, and this one you had to cut into 7 pieces, that one you had to cut into 5, and you've got 35 total blocks. It gets to be a little bit cumbersome to draw pictures that big, which is why we have these shortcut rules of, just multiply straight across the numerator and denominator. The next one, 4/9 times 1/9. All right, now don't get confused here. Just because these have the same denominator, it doesn't matter, it doesn't change what the rule is. The rule for multiplying fractions is multiply straight across. 4 times 1 equals 4, 9 times 9 equals 81, 4 out of 81. All right, that's my solution to 4/9 times 1/9. Right, again, if I were to draw a rectangle of that, I would have 9 pieces on this side and 9 pieces on that side. That gives me a total of 81 pieces in the block. And then 4 times the 1 to fill in would give me 4 pieces filled in out of those 81. All right. The next one, 5/8 times 13/17. All right, so once again, multiply straight across. 5 times 13 is 65. 8 times 17 is 136, which I just cheated and looked down. Don't know if you noticed that, but I had the answer written on a piece of paper in my lap. So we get 65 out of 136. And this one cannot be simplified, and I know that by looking at the original numbers here. The 5, the 8, the 13, and 17, none of them have any common factors, which if your original things that you're multiplying don't have common factors, that means your answer at the end doesn't have any common factors. Right, so here with the 4/9 and the 1/9, the 4, the 1, and the 9 don't have anything in common, so I know right away that I won't be able to simplify that when I get my answer. All right. Hopefully those made sense to you as far as just pretty basic multiplying fractions. Just multiply the numerators, multiply the denominators, simplify if you can. I'm going to pause the video again and put up some other stuff, like little things that come up here or there when you're multiplying fractions that aren't different. They're just a little bit not exactly the same, different. All right, so here is another example. Like I said, it's not really different. It's just something a little bit not the same as what we had a minute ago. 3/2 times 3/5, right? So in this case, what's a little bit different here is that one of my fractions is actually bigger than 1, right? Well, that doesn't change how we multiply the fractions together. So like I said, it's not really different, it's just not quite the same. Right, so 3/2 is more than 1 multiplied by 3/5, which is still less than 1. So if I want to do this with the blocks, in order to do 3/2, excuse me, I need more than one whole here, right? So here I have 1, right? These 2 blocks here represent 1 that's cut into 2 pieces. And then this 1 down here, these 2 blocks, that represents another 1 cut into 2 pieces. So to get 3/2, I have to do both of these, right? That's 1 whole plus another half of that second whole, right? So, right, this is 3/2 right here, right? 1 and 1, right? Each cut into half. I take 3 of those halves. Right, for the 3/5, right, across the top I had that just represents 1 whole, right? cut into 5 pieces, and I want to take 3 of those pieces, 3 out of those 5. All right, so it's 3 halves times 3 fifths, right? And so if I see where they intersect, well, I get a total of 9 blocks where they intersect, right? 3 on this side and 3 on that side. So I get a total of 9 in my intersection. Now, to get my denominator, though, this time, I don't count all those blocks, right? What each of these little blocks here represents, each of these little blocks represents 1/10, right? Because when I did ignore this bottom one for now, when I did my 1 times 1, it was 2 on this side and 5 on that side. That one block there was split into 10 pieces, right? So each one of these blocks represents 1/10, and I have 9 of those 1/10 blocks filled in, so I have 9 tenths, right? I hope that makes sense as far as looking at it in terms of the picture. Now, mathematically, to actually figure this out, I do the same thing I did before. The rule for multiplying fractions, that rule doesn't care if your fractions are bigger than 1 or less than 1 or negative numbers or whatever. When I'm multiplying 2 fractions, I multiply the numerators, so 3 times 3 is 9. I multiply my denominators, 2 times 5 is 10. 3 halves times 3 fifths equals 9 tenths, right? Again, showing you, visually why that works. Hopefully that makes sense. If it doesn't, just keep in mind, when you're multiplying fractions, it doesn't matter. You just multiply straight across the top and straight across the bottom. All right, so that is when we're multiplying by a fraction that's bigger than 1. I'm going to pause the video again here and put up another example where we multiply a fraction times a whole number. All right, so here we have the problem 5 times 2/3. All right, so now we have a whole number multiplied by a fraction. All right, so what I did here, across the top, right, that represents 1, is split into 3 pieces. So my 2/3 are going to be 2 out of those 3 pieces along the top. Right, to do the whole number 5, I actually have to do 5 1/2s, if that makes sense, right? So this is not like something split in, it's not like 1 whole split into 5 pieces so that each one is a fifth. This is 5 wholes, which equals the whole number of 5. Right, so I need to do all 5 of these, right? That represents the whole number of 5. And when I do the intersection here, right, it's all 5 of those times the 2 out of 3 that are going across the top. So I end up with a total of 10 filled in, and each one of those little blocks represents 1/3. All right, think about it this way, right? This is a 1 by 1 block here. Right, it's 1 here and 1 across there. So that means that equals 1 whole. It's cut into 3 pieces, so each of those blocks equals 1/3, 1 out of those 3. Right, so what I have then is I have 10 blocks filled in. Each of those blocks represents 1/3. So what I have is a total of 10/3. Right, to do that by hand without drawing the picture, right, if I'm doing 5 times 2/3, well, if I'm multiplying fractions and I have a whole number here, I can write that whole number as a fraction, 5/1. Right, 5/1 is the whole number 5. And then I can multiply straight across. 5 times 2 equals 10, 1 times 3 equals 3, so I get 10/3. Right, the rule of thumb is when you're multiplying a whole number times a fraction, the whole number multiplies your numerator, only your numerator. Right, the 5 multiplies the 2. The 5 does not multiply the 3 as well. I've seen a lot of people in the past multiply 5 times 2/3 and make it 10/15 because they multiplied the 5 on the top and the bottom. Right, as we see, when we turn that into 5/1, that 5 only multiplies the numerator. It only multiplies the 2 in this case, and the 3 multiplies the 1, so it stays a 3 in the denominator. All right, so that's how we can multiply a whole number times a fraction. So that's multiplying fractions, right? Whether you have a whole number, whether your fraction is bigger than 1 or less than 1, you just multiply the numerators, you multiply the denominators. That gives you your solution when you're multiplying the fractions.